We're going to look now at graphing log functions using transformations. And these are the same rules of transformations that we used earlier in the semester. We're just applying them now to log functions. So when we know the shape of some log function, if we see something added or subtracted outside at the end, this is going to be a shift up or a shift down. So this is a vertical, just like before, vertical transformation. If we see something being added or subtracted, and now that addition or subtraction is happening inside the parentheses, this involves an X. So we are going to be shifting. If it's positive, we're going to be going to the left. And if it's negative, it's a subtraction, we're going to be shifting the graph to the right. Same as before. In terms of reflections, if the negative sign, if we see a negative sign outside in front, this is going to be a reflection about the x-axis. In other words, here, what this means is if we have the point, where can I fit this in? Over here. If we have the point xy on our graph, then we're going to have the point x. We're not going to change anything with the x, but y now is going to be negative. We're going to, actually not negative, we're just going to switch the sign of whatever our y was. So when the negative sign, when the subtraction sign is outside, you flip the sign of the y in the coordinate pair. When you have the negative sign inside with the x, if we have the point xy on our log function, the new point that we're going to graph, it's the x that's going to have its sign change. So this results in a reflection about the y-axis. These are a little tricky. I think it's best to remember this information here. As I said earlier, the log functions are not easy to graph manually. So in terms of using transformations to make the vertical or horizontal shape changes, the shrinks and the stretching, those are best done either using technology or making a table of values, because our basic graphs, when we're graphing log functions on paper, as we know, the values get very big and very quickly, get very big and very small quickly, so the graphs are not all that accurate. So to start changing the shape, they would become even more inaccurate using these transformations. So we're, again, make a table of values if you needed to do this, or use technology. So let's look at one example here. And whoops, a little too crooked. So we are going to start with our basic function here that we looked at earlier. That is, and I'm going to call this f of x, is going to be equal to our log base 3x, okay? We can see log base 3 there. So let's graph this. So we have, we know we have the point 1, 0, and we had the point 3, 1. This was from our early example. And then we have the point 1/3, -1 there. And I will, and then I do have the point here, 9, 2. So let me put that in too. So here is our f of x. Here's our f of x, okay? And now let's take a look at some of the changes that we are seeing here. I'm seeing this -3 inside parentheses, so that's going to be a horizontal change. And then I am seeing this +2 on the outside. So that is going to be a vertical change. So I'm going to do the horizontal change first. So minus 3. So we're going to move each point to the right by 3. So this point here, 1, 2, 3, sits here now. This 1/3, that's a little bit, we have to estimate. 1, 2, 3, that's there. And now this point here, 1, 2, 3. And that point would go off the graph, so I'm going to leave it. So we have, connecting the dots, we have this now, which is log base 3 x minus 3. We're not done, but we've done the horizontal. Now, let's take a look at the implications of the vertical change. So we're going to go up 2, plus 2. So this point here goes 1, 2. It's there now. This point here goes up 2, 1, 2. It's there. And you can hardly see that one. And this goes up 2, 1, 2. So it's there. So when I connect these, this is the final graph. 2 plus log 3 x minus 3. So this blue represents our final answer after both changes. So let's look at this here and identify some information. Here is our vertical asymptote. So our vertical asymptote is now x equals 3. So this horizontal shift that we had, since our asymptote was x equals 0 originally, we've moved it over 3. Our new vertical asymptote is now going to be x equals 3. Let's take a look. No surprise here. Domain and range. The domain here has to do with all our x values. So for our original function, the domain was 0 to positive infinity. We've moved it over by 3. So now our domain starts at 3 to infinity. So our domain would be 3 to infinity. And then our range, it's negative infinity to positive infinity. That's not going to be impacted at all by any of our changes.